In this video, I will try to explain about how to understand the reading of LEL, gas measuring equipment, and we will explain it from two perspectives. One is for man entry purpose and the other one for tank cleaning purpose. From ISGOTT, we get very clear guidelines that how should be the LEL reading before man entry in enclosed space. If we go to latest edition of ISGOTT, then we will get it from there. This is the latest edition of ISGOTT, that is the 6th edition. Here you can find under 10.7.2 atmosphere test before entry. Very clearly it is said oxygen requirement 21%, flammable vapor, that is the hydrocarbon, is below 1% of LFL. So we can write it here, below 1% of LFL. That is the requirement, below 1% of LFL before entry of personnel. Just here we need to understand 100% LEL indicates the LFL value of the particular cargo. We use the same sensor for all the cargos, and industry has set the guidelines like this way. 100% LEL indicates LFL of that particular cargo. Whatever cargo we are concerned or we are talking about, we don't need to do any other manual calculation. If on the instrument it is less than 1% or 1%, we can accept it for man entry. And for the purpose of tank cleaning, chapter 12 shipboard operation, tank cleaning flowchart is there. Page 226 you can see there are two conditions for tank cleaning. One can be inerted, other can be non-inerted. As I already discussed few minutes ago that if the oxygen is below 11%, there will be no fire. But as per SOLAS requirement, if it is below 8%, only in that case it is considered inerted condition. So if it is inerted condition, it means there will be no fire at all. The possibility is zero. So you can start tank cleaning without worrying at all about the LEL or the hydrocarbon presence. But if the atmosphere is not inerted and we need to do the tank cleaning operation, in that case we have to follow this flowchart. Here it says, is the cargo tank in inerted condition? If it is yes, then directly you can go for tank wash. But if it is no, then it says you have to follow below flowchart. So we will see what it says. Non-inert cargo tank, O2 not contained as below 8%. Tank bottom and piping system flush, followed by tank ventilation. So it says you have to do the flushing and then you have to start the ventilation. Then we have to go for measuring the LFL at the present situation. It says ventilate. That means as it is not inerted, we have to ventilate the tank to reduce the concentration of hydrocarbon. Because it was cargo before inside the cargo tank, there is highly chances to get the hydrocarbon more than the LFL and below the UFL within the hydrocarbon, within the flammable range. If we get it within the flammable range, that means it is very, very hazardous for fire. The fire will happen only just with the help of a spark. Before starting tank cleaning, the requirement says it has to be below 10%. Less than 10% of LFL. So if the instrument shows less than 10% LEL, we can directly accept it. And during the tank cleaning, it can be within 10 to 35% LEL. So time to time we have to check. If required, we need the ventilation. If not required, we can continue the operation. So the basic funda is we have to keep in mind 100% LEL indicates the LFL value for that particular cargo. And the value of LFL is not same for all cargos. It is separate for separate cargo. Like we are talking about methane, it is 5. If we talk about isobutane, maybe around 1.8. If we talk about the gasoline, it could be something like say like 2. So for the different cargo inside the same tank, if we count 100% LEL, let's say for gasoline, 100% LEL means it will be equivalent 2% by volume. So simply 100% LEL will indicate it is completely entered into the explosion limit, flammable limit or explosion limit or fire hazards limit, however you can describe it.
And from here till reaching UFL, that is upper flammable limit, it will remain flammable within this range. And our target is to remain outside, well outside from this limit. And that is why the industry set this 10% or 1% below 1% guidelines, which is having very wide margin from the flammable limit. So now question may come that which gas is used for calibrating this hydrocarbon sensor. If you check it closely, most of the equipment you will see it is calibrated with isobutane. And if you compare with the LFL and UFL value for isobutane, it is something like LFL value is about 1.8. For the case of methane, LFL value is 5. But as it is calibrated with the isobutane, so you are in the more safer way or more safer limit. That is how the industry is handling the hydrocarbon sensor reading and the understanding of this for our practical purposes. The hydrocarbon sensor is not changed for different cargoes. It is the same hydrocarbon sensor, and we are using as per the industry guidelines. And also need to add that we are getting the hydrocarbon value in two ways, either in percentage of LEL and other one is by volume. So some equipment can interchange automatically from percentage to volume, and some equipment you have to change. Once it is 100% LEL, it indicates for you that it is percentage by volume as per the LFL value for that particular cargo. And from here you can switch to volume so that if you need further value in volume, you can directly get it as part of as a percentage of volume. So that's it. That's how we can be very sure about our practical situation inside the cargo tanks or any other confined space or enclosed space we are talking about, and we can act safely. Thank you so much for watching this video, and I hope to meet you in next video.